This one would have been 6. This one would have just been 1. This one would have been 8. And this one would have been -1. Does anyone want me to do any of these bottom 4 here? Or any of them, really? Sorry, Jordan? This one, you want to know how to do this one? That's an 8, yeah. Okay. Well, because of the way roots behave, they in BEDMAS are the same as doing an exponent. So we're going to do them first. The square root of 25, if you punch that in your calculator, is 5. The square root of 81 is 9. And so your equation is going to look like this. And now we continue following BEDMAS. 9, we're going to do the division first. 9 divided by 3 is 3. So this is going to become 5 plus 3, which is 8. Jordan, that makes sense? Kind of, sort of? Bless you. Bless you. You sneezed. Some of you asked me about these ones yesterday, and you said you guys just cut them off. We want to make sure we're rounding them. So like with this first one, if you want to cut it off after 2 decimal places, don't just cut it off and say, well, it's 2.23. If you want to end it at 2 decimal places, you need to just look at this guy here and round the thing properly. Rounding this thing to 2 decimal places is going to make this 2.24 if it's properly rounded. So don't just cut off decimals that go on forever. You got to make sure that if you're going to do that, you got to round properly. But for imperfect squares, you are welcome to, write down everything your calculator provides. So this is what we were looking at yesterday. Today is going to be similar to it. We're going to look at an extension of it. We're going to look at perfect cubes. So flip to this page. So similar kind of stuff. Let's give her. So if a square root is a number that multiplies by itself twice to give the original number, for example, the square root of 4 was 2 because 2 times 2 was 4, and the square root of 25 is 5 because 5 times 5 is 25. And these things were based on looking at a square. So if this thing has a particular area, the area is equal to, because it's a square, the area is equal to a length times a length. To find the length, all we're going to take the square root of the area. So the square root of the area, yes, Ethan, is equal to the length. You betcha. Would you? I have both. Which one would you like? Pencil? There you go, sir. So this is what we looked at yesterday, which was a review of stuff you did in grade 8. The idea of the square root being the length of a square, or what number multiplies by itself to give you a perfect square. Today we're going to look at cubes. So the cube root is a number that multiplies itself how many times? Square was twice, cube is 3 to give the original number. And it comes from looking at a cube. Now, a cube means I've got all of these sides are the same length. If I take the length on a cube and I multiply it by itself twice, that's going to give me the area of one of the sides. If I multiply it by a second or a third length rather, what's that going to give us? What do we get when we multiply a length by a width by a height for an object, like a 3D object like this? Does anyone remember? Yeah, Dakota. Yeah, and through how do you figure out, so what concept is related to how much space a 3D object takes up? Starts with a V. Close. The volume. So square root is related to the side length and an area. The cube root is related to the volume. The volume of an object, or the volume of a cube in this case, is equal to a length times a length times a length. Length, width, and depth, but they're all the same for a cube. So if I'm given the volume of a particular cube and I want to find just the length of one of these sides, what we're going to do then is we're going to look at taking the cube root of the volume, and that's going to give us the length of one of the sides. So with the cube root, we actually have to put the 3 here. With the square root, we didn't have to put anything because it's assumed using this notation that this is a square root because there's no such thing as a 1th root. We could have put the 2 here just as easily. We don't have to. But when you're dealing with a cube root, you absolutely have to put that 3 there, just like these guys here. So the cube root is a number that multiplies by itself 3 times to give the original number. And so, for example, the cube root of 8 is, what times itself 3 times gives you 8? Well, we have a handy dandy calculator for that. So all your calculators are going to handle this differently. The Casio, if you have a Casio, has 2 different options for using this. The Casio has a button, so the square root button is there. Above the square root button, there's a 3rd root button. That is the cube root symbol, which you could use. Or it's got this symbol here, where you've got the box root box. I want to show you what happens if I use box root box. On the Casios, if that's the calculator you have, and you want to access this, we're going to push Shift, and we're going to push that button, and it opens up this. It's a root symbol with 2 boxes there. Now you can put whatever numbers you want in these 2 boxes. So if I want the cube root of 8, I'm going to put a 3 in that box. I'm going to move the arrow over to move to the other box. I'm going to put the 8 in there, and I'm going to push the arrow again to move out of that, and now I've got the cube root of 8. I hit enter, and it's 2. If you're using one of the TIs, so some of you may have the TI calculator in front of you, and Jared does. The TI is a little bit different. The TI, if you look down here, above the symbol for the exponent, there's an X root button. So if you want to take a if you want to take a root that isn't a square root, and you have this kind of calculator, that's the symbol you're going to need. Before we can use it, you have to put in the number for the kind of root you want. So we want a cube root here, so I'm going to push a 3, then I'm going to push second function, and I'm going to push this button here to get access to this X root notation. What this thing does is it takes the number that's right here, puts it where the X is, then we're going to add brackets and an 8, and the cube root of 8 is 2. So depending on which calculator you have, I like the Casios better, but as Hassan was complaining yesterday, I don't necessarily have enough Casios for you all to have Casios. So the cube root of 8 is 2 because 2 times 2 times 2 is equal to 8. 2 times 2 is 4. 4 times 2 is 8. Good morning, Riley. How are you? Oh, did I get Priyasha? I did not get Priyasha. So what's the cube root of 64? It is 4. Because 4 times 4 times 4 is equal to 64. 4 times 4 is 16. And then 16 times 4 is 64. And you've got calculators now. You can still use your multiplication tables, but you've got the calculators here too. So these are the first 8 perfect cubes. You don't have to memorize them, though it will make your life a little bit easier to do so. The cube root of 1 is 1, because 1 times 1 times 1 is 1. This guy we saw already was 2. This guy we saw already was 4. And the rest of these are just going to fill in order. The cube root of 27 is 3. The cube root of 125 is 5. Cube root of 216 is 6. 343 is 7. And 512 is 8. We may as well round this off and do the first 10. So let's put those under here. The cube root of 729 is 9. And the cube root of 1000 is equal to 10. Now, these are handy numbers to recognize, but you are going to have a calculator for all of this, so it's not the end of the world. You are allowed to use a calculator for everything we're doing moving forward, actually, the rest of the semester. No. This was, I mean, if you're asking, this is the exact same point that all of my classes get the calculator for the rest of the semester. Ooh, it's not hanging there anymore. Zach, you reminded me. Was it yours, the black hoodie that was hanging on? That was yours? You took it? Fantastic. Okay. So, likewise, we can use cube roots to find the cube root of fractions and decimals as well. So I'm going to show you again what these look like on your calculator. If you want to take the cube root of a fraction, your calculators don't do fractions nicely, but a fraction is just division. So if I want to take the cube root of something on the Casio, I'm going to open up my box root box. I want to take the third root of, and now I want to put a fraction in here. A fraction is just division. I'm going to go 1 over 27. And on the Casio, you can see that it's going to take the square root of this whole thing, or sorry, the cube root of the whole thing, because the root symbol continued to grow. This is a problem Jordan was having yesterday on your calculator. The root symbol kept going and covering over the numbers. So the Casios will actually give it to you as a fraction. The TIs, I think, will give it to you as a decimal. The TIs, you have to do it slightly differently. Again, because we want a cube root, you have to put the 3 down first. Then we're going to go second, and then the X root button. Now, to make it do a fraction, on the TI, you actually have to open a bracket. Put 1 divided by 27 inside there, and close the bracket. If you don't put a bracket there, it'll just do the cube root of 1, and then divide that by 27, which doesn't actually do anything. So you have to put the bracket there, put your fraction inside, close the bracket, and there's your 0.3 repeating. Does anyone have a calculator that they're struggling with? Yes. Which thing? Oh, on you're using Casio, Jordan? Yeah. So you're going to push Shift, and then you should have a symbol looks like this one. Shift is up here, Jordan. Look. This button right up top here. And then this guy down here. Because you want that symbol right above it. So you should get something that looks like this on your screen. Do you? Oh, no. Do you have this? Look at the screen. Do you have this on your screen? Yeah. Okay. So you can see a little flashing right there. You're going to put a 3 up there. Then you're going to push the arrow button like this. Mine's a circle, but you should have arrows there. So your cursor goes down inside there. Now we're going to put 1 over 27. And you can see the line keeps growing. I'm going to push the arrow again to get outside of the root. That's divide. Because a fraction is division. And now hit enter. And now the Casio should give it to you as a fraction. If you don't want it as a fraction, you push this SD button down here. Fraction, repeating notation. There's the value. So this guy is going to be a third, which is also 0.33333 repeating. What's this guy? What'd you get? What is the cube root of 1.125? Yeah, Denny. Excellent. So one of these is a perfect cube and the other is not. This guy right here is a perfect cube because you can have it as a fraction, or you can have it as a repeating decimal, or you can have it as a decimal that ends. This one here goes on forever. There is no repeating decimal. It is just a mash of numbers. This is not a perfect cube. Now, one thing I didn't cover yesterday that I'll talk about now is, can you take the square root of a negative number? For example, could I do the square root of -4? If you recall what it means to have a square root is I want to take a number and I want to multiply it by itself to get me this thing. Does such a number exist? Why not, Dakota? You're just pretty sure it doesn't? You're right. What are the numbers that could multiply to 4? Well, that is going to multiply by itself is going to be 2, right? Well, 2 times 2 is +4. -2 times -2 is +4. Punch this into your calculator. What does your calculator tell you happens when you take the square root of a negative number? Your calculator should all do something different. Yeah, Dakota? Yours says math error. Says what? Try that again. What kind of calculator do you have? Using a Sharp calculator. And you took the square root of -4? Weird. Error. That's what I want. So, Dakota, what kind of calculator do you have? Casio? Which one? Okay. And yours says math error? Okay, if I do the square root of -4 on the Casio, it says math error. On this calculator, it says a domain error. This is because, so this doesn't work. A negative times a negative equals a positive, and a positive times a positive equals a positive. So you cannot take the square root of a negative number. But can you take the cube root of a negative number? Can you have a number that multiplies by itself 3 times to give you something negative? You assume so. Because I'm sounding enthusiastic, I sound like I'm different. Well, you can. So the square root of -4, this is going to give you an error on your calculator every time. Whether it's a math error or a domain error. But this guy, you can multiply 3 of the same thing together and get a negative value. What does that thing have to be? It must be -2. The cube root of -8 is -2 because -2 times -2 times -2. These two are going to give you +4, but you're going to multiply by a -2 again, and it'll give you back -8. You can take negatives of odd roots, you can take odd roots of negatives, but you can't take even roots of negatives. Okay. So we've done this top piece already because I've been giving you guys your calculators already. So we're going to hold off on this. We're going to skip this for a second. It'll be part of the work I give you for homework in a moment. But I want to look at this piece down here at the bottom first, and then I will free you. So again, I've tried to make it clear at the beginning of each of yesterday's lesson and this lesson that the idea of the cube root and the idea of the square root come from real shapes. So let's draw a square over here. Do your best to draw me a square. It doesn't have to be perfect. And then over here, I want you to try and draw me a cube. So you're going to start by drawing a square face. Then you're going to draw a diagonal line backwards. Try your best, draw me a cube. And if you want to make it look really 3D, let's draw the dotted lines on the inside. There, I've got my square, I've got my cube. Now for each of these, I'm just going to label the sides as L. L just means length. Just to demonstrate that these are all the same. So the square is a length times a length. The cube is a length times a length times a length. So area is going to be length times length. Volume is length times length times length, whatever it is. So to go the other way, if I want to find what the side length is, all I got to do for the square is take the root of the area. That was why this notation was developed in the beginning. And to find the side length for a cube, I just need to take the root, in this case the cube root, of the volume. So side length to volume, that's just going to be length cubed. And side length to area is just going to be length squared. So for example, if I told you that the side length of the square was 3, what's the area going to be? If the side length is 3, and the area is a length times the length, area is just going to be 3 times 3, which is 9. If I told you the volume over here was 27, and I wanted to go back and find the side length, all I would have to do is take the cube root of that volume. So the cube root of 27, we already said, was 3. So this relationship exists that goes back and forth between either length and area or length and volume. And that's it. That's all we're doing today. So what I'm going to give you guys to do is I would like you to do these 6. Again, it's more practice with your calculator. Then I want you to flip the page. And I want you to do this page. And that's it. You can do it. I believe in you. You're going to have to follow BEDMAS down there at the bottom. And we love our BEDMAS. BEDMAS is not really going to show up next chapter. We'll take a break from BEDMAS for the next chapter. It'll come, yeah, we're going to do reverse BEDMAS after though. The wild ride. Okay, there you go.